Hello everyone, in this lesson we are going to learn about linear inequalities. To solve linear inequalities, we use similar methods to those for solving linear equations. Well, the solution of an inequality is the set of all real numbers x that make the inequality true. Simulate the set of values for which two inequalities are true at the same time. When solving the linear inequalities, we usually use the number lines. Now let's do some example to see how does the number lines work. How do number lines work? So first one, there is a set of values x greater than -3 and x less than and equal to 2. So firstly, we need to draw a number line. So we have this is 0, 1, 2, 3, and here -1, -2, -3. In here, we can see the first one is greater than -3, so we find the point -3. When you see inequalities that is greater than, so you need to use the empty dot. And the greater than, so it's on the left-hand side, or on the right-hand side. So for the right-hand side of the -3, that is x greater than -3. And then we see x less than and equal to 2. We find the number 2 over here, and that is with equal, so we need to use the black dot. And less than that, so we need to draw a line that is on the left-hand side of the 2. Those are the numbers less than and equal to 2. And the overlap area is this part. Is the solutions for the set of inequalities. So we have overlap area is the solutions for the set of inequalities x less than or equal to 2 and greater than or -3. And we can also write in the set notation. That is x that's -3 less than x less than or equal to 2. We can see we can see in the number lines there are two types of dot. The first one is empty dot. That is when you see the less than and greater than. And when you see there is a black dot, so that is less than equal to and greater than equal to. It includes the end value. Now let us see another example. The set of values x less than -2 and x is greater than and equal to 1. So we need to draw a number line first. We have 0 and 1, 2. So -1, -2. So for the first one, less than -2. So it's on the left-hand side of the -2. And we see this is just less than. We do not include equal to. So we use the empty dot and less than on the left-hand side. So for this part. And the second inequality, we have x is greater than or equal to 1. So we need to find the value 1 over here. And it includes the AND values, so we need to make the black dot. And then we need to find the direction that is greater than, so it's on the right hand side. As we can see, there is no overlap, which means there are two set of values for which two inequalities are true at the same time. So two inequalities have to be written separately. As x less than minus 2 or x greater than or equal to 1. So that is how do number lines work in the question. Now let's do some exercise. For the first question, you need to find the set of values of x for which the first inequality, that is 5x plus 4 less than 3 minus 2x, where the inequality 1. And the second inequality, that is 6x minus 3 greater than 4 plus 2x. So let's first solve the first inequality. So 5x plus 4 less than 3 minus 2x. Then what we do the similar way as we do in the equations. Yeah, in the inequalities. So we have 5x plus 2x less than 3 minus 4. We have 7x sorry, I wrote the wrong question, that it should be greater than. Sorry for that, my mistake. So greater than, so this is also become greater than. And greater than minus 1. So x greater than minus 1 over 7. And for the second inequality, we have 6x minus 3 greater than 4 plus 2x. It implies that 6x minus 2x greater than 4 plus 3. We have 4x plus greater than 7, x greater than 7 over 4. And then we need to find the set of solution. So we need to draw a number line. So here we have 0, here is 1. So 7 over 4 is greater than 1, less than 2. So probably over here, I guess. 7 over 4. And we have minus 1 over here, and minus 1 over 7 is less than that. So probably and close to 0. So probably here. And what we have x greater than minus 1 over 7. So we have empty dot greater than on the right hand side of that. So for this part. And the second one is x greater than 7 over 4. So we find that 7 over 4, the empty dot, and then greater than on the right hand side of that. So, and we need to find the overlap area, that is this part, which implies the solutions of the inequalities is x greater than 7 over 4. So we can see that x greater than 7 over 4 made the two inequalities true at the same time. Now let us see the second example. So we have the first inequality, minus 4x plus 6 greater than 10. We set as the inequality 1. And the second one is 11 less than or equal to 10 plus 2x. We set inequality 2. So we need to solve them separately. We have inequality 1, that is minus 4x plus 6 greater than 10, implies that minus 4x plus 10 minus 6, so minus 4x greater than 4. To be aware of that, you need to divide by minus 4 for the both hand side. When you divide the negative numbers, you need to change the sign. So that is x less than minus 1. For the second one, we have 11 less than and equal to 10 plus 2x, implies that 1 less than and equal to 2x. So x greater than and equal to 1, greater to half. Then we need to draw the number line. So we have a number line that is, so here is 0, here is 1, half is over here, and minus 1. So firstly, we want to draw x less than minus 1, so we need to use the empty dot. And less than minus 1 is on the left-hand side of the minus 1. So on the left-hand side, another one, so x greater than and equal to half, so we use the black dot, half, and less than, x greater than and equal to, so it's on the right-hand side of half, that over here. As we can see, there is no overlap, which means we cannot find the set of values that make the two inequalities true at the same time, which means this one, we don't have the solutions. So no solutions. In detail, if we find a number that is minus 2, for example, so minus 2, it satisfies the first inequality, but it's not in the x greater than and equal to half, which means it does not satisfy the second inequality. So the no overlap area means that there is no solutions for those two inequalities. Here is a conclusion for this lesson. So in this lesson, we learned that the solution of two inequalities is a set of values for which two inequalities true at the same time, and we usually use a number line. So the empty dot is when you see the less than and the greater than, and the black dot when you see the less than or equal to and the greater than equal to, include the and value. And when you see the overlap, there are the 4 types, and no overlap area, which means you need to write inequalities separately using all. And when you find in the set of values for two inequalities, the overlap area means the solution, and if there is no overlap, which means there is no solution for two inequalities. Well, thank you for your watching. Hope you enjoy it. Bye.